The most dangerous idea in Deep Impact is also the most comforting one, that if you can just blow the comet apart, you can turn doom into fireworks. In real physics, that is almost backwards. Fragmentation can become a shotgun blast, not a solution. Deep Impact, released in 1998 and directed by Mimi Leder, treats the threat as a public crisis, not a swaggering action job. A teenager, Leo Biederman, first spots the object. Astronomer Marcus Wolf confirms it, then dies in a car crash, delaying the warning. The comet gets named Wolf-Biederman. Governments try secrecy. A journalist pulls the story into the open. Meanwhile, the clock runs in months, not years. Here is the first big scientific hinge. Warning time is everything. If you nudge an object's speed by a tiny amount early, the missed distance grows with time. If you act late, you need violence, and violence is unpredictable. Deep Impact gets that right in spirit. The danger is orbital. The real solution is orbital too. Change the trajectory so the center of mass misses Earth. The film's compressed timeline is part of its drama and part of its fantasy. Discovery, confirmation, orbit calculation, mission design, spacecraft readiness, crew training, launch, intercept, failure, and impacts. All arrive at blockbuster speed. In reality, each of those steps fights uncertainty. Long-period comets can be especially nasty because they may approach fast, from poorly constrained orbits and from directions hard to observe, including near the sun's glare. So late discovery is not impossible. Still, the movie stacks every delay on top of every engineering miracle. Next, consider the Messiah mission itself. The astronauts rendezvous with a rotating comet, land, anchor, do spacewalks, and drill deep enough to plant nuclear devices. Each of those is hard. Together, they are extreme. A comet nucleus is not solid ground. It is likely low gravity, irregular, dusty, icy, and mechanically weak. It can have cliffs, pits, boulders, and jets that switch on with sunlight. Even the act of drilling pushes back, and in microgravity, pushback can lift you off the surface. Anchors can fail if the top layer is just a fragile dust mantle. The movie deserves credit for making the surface hostile. It is dark, jagged, and unstable, not a neat metal ball. That visual instinct fits what we infer about real comet nuclei, but the operation is still far too forgiving for a first-of-its-kind, crude comet drilling job done under extinction-level time pressure. A real attempt would want extensive prior reconnaissance. You would want a shape model, rotation state, mass estimate, density, surface strength, and activity map. Without that, you are drilling into a moving unknown. Now to the nuclear plan, and the key word is coupling. In space, a nuclear explosion does not create a familiar atmospheric blast wave. Much of the energy can radiate away. What matters is how much momentum you transfer to the target in a controlled direction. Deep Impact actually shows good intuition here. The plan is to bury the devices, not just detonate near the surface. Subsurface emplacement can, in principle, couple energy better. It can heat material, excavate ejecta, and produce a push. But then the hard truth lands. Knowing the yield is not enough. The effect depends on burial depth, porosity, volatile content, internal fractures, and geometry. A weak, icy, dusty body might vent through cracks. It might split along old fault lines. It might kick fragments off in directions you did not plan. The film's outcome, 2 clean fragments, is dramatically tidy. Reality could be messier, and therefore riskier. That leads to another strong lesson the movie accidentally teaches. Fragmentation is not deflection. If the pieces stay on Earth crossing paths, the total incoming mass and the total kinetic energy mostly stay. You have not erased the disaster, you have rearranged it. The Atlantic impact sequence is a good example of real hazard in cinematic form. Ocean impacts can generate huge disturbances. They can excavate water, vaporize material, launch ejecta, and drive powerful waves. Coastal infrastructure is fragile under fast-moving water loaded with debris. Deep impact is right to say that it hits the ocean is not comforting. Modern civilization is coastal, and that is exposure. Still, the wave in the film behaves like a moving wall, tall and clean, racing between skyscrapers. Real tsunamis are long waves. In deep water, their height can be modest compared with their wavelength. Near shore, they slow, steepen, and inundate, with damage tied to flow depth, velocity, duration, debris, and repeated surges.